Hello everyone, for this video we're going to talk about arithmetic series. Now what is our learning target for this video? Hopefully everyone will be able to determine the sum of an arithmetic sequence after watching this video. And so first, what is arithmetic series? It's the sum of the first n terms of an arithmetic sequence written as S sub n equals first term plus second term plus third term plus fourth term and so on. Okay, so here is our first formula to be used in finding the sum of an arithmetic sequence. So if a sub n is not given, you may use this formula. And this will be our second formula to find the sum of arithmetic series as well. So this will be used if a sub n is not given. To give you an emphasis, guys, so this would be S sub n, this is the sum of n terms, n would be the number of terms, a sub 1 is your first term, and a sub n is your last term. So by the way, in this video, I'm gonna focus with the use of the second formula, the shorter ones. But don't worry, I'm gonna give you sample solutions wherein we make use as well of the first formula I presented, the longer ones. Okay, so let's have our first problem. So here, find the sum of the first 25 terms of the arithmetic sequence, 7, 23, 29, 35, 41, and so on. Okay, so here, before we solve this problem, of course, you need to understand first the problem of what will be the task you are supposed to do. So here, you need to find the sum of the first 25 terms. Now, you need to consider first what are the given data here. So you need to sort out first. So here, let's find out the common difference first by subtracting second term by the first term. Okay, so 23 minus 17, it's 6. And if you're going to check as well with the other consecutive terms, you may have 29 minus 23, it's 6 as well. 35 minus 29, it's 6 as well. Therefore, we can say that it is an arithmetic sequence because they do have a common difference, which is 6. And aside from that, what else are the given data here in the problem? So you can see we do have our first term, which is 17, our n, which is 25, and our d, which is equal to 6. So actually, guys, to find the sum of the first 25 terms in this problem, I'm gonna use the shorter formula first. So later on, I will show you as well on how are we going to use the longer formula. Okay, so of course, if we're going to use the shorter formula, which is S sub n equals n over 2 multiplied with a sub 1 plus a sub n, we need to identify first the value of our a sub n, or the 25th term, because here in our data, in our problem, it is not yet given. And so, prior to the use of the formula for arithmetic series, the shorter ones, you need to identify first the value of your a sub n so that you can freely use the shorter formula. And so, to find the value of the 25th term, so you need to use the arithmetic sequence formula I presented last time. So here, so just simply substitute all the given data, the first term, which is 17, the n, which is 25, and the d, which is 6. And so you need to change as well. The a sub n will be turned into a sub 25 to indicate that you are looking for the 25th term. And so, perform the indicated operation, you would have 24 times 6, 144, and lastly added with 17. And we can see that the 25th term of the given sequence is equal to 161. And now, since we all know already the value of the 25th term, we can now proceed with the summation of the given sequence. Okay, so right now, I'm gonna use already the shorter formula, but I would like to start with indicating all the necessary data in the formula. Your n, your a sub 1, and your a sub 25. And so, let's substitute here in the shorter formula for arithmetic series. So we have our n, we have our a sub 1 here, which is 17, and a sub n, which is 161. So performing the indicated operation, 17 plus 161, it's 178, multiplied with 25, and then divide with 2, or else you may also simplify first. 25 divided by 2, it's 12.5, and lastly multiply with 178. And so you got the sum already of the first 25 terms of the sequence, which is 2,225. Okay, so here I'm gonna show you the other solution using the longer formula for arithmetic series. So here, you need to indicate as well all the given data that we need for the longer formula of the arithmetic series that we are going to use. So n is 25, a sub 1 is 17, and b equals 6. And so, I'm gonna substitute it here already in our longer formula for arithmetic series. So we have our n, which is 25, a sub 1, which is 17, n is 25 as well, and b, which is 6. And so, of course, applying the PEMDAS rule, we need to perform the indicated operation first here inside the braces, guys. So we have 2 times 17, it's 34, and we have 25 minus 1, it's 24. And of course, let's multiply first 24 by 6. You would have 144, then combine with 34. And lastly, let's multiply it with 25 divided by 2, or the simplified form of that, which is 12.5. And so we will be able to get the same answer with the previous solution that we've got for the shorter formula of arithmetic series, which is 2,225. We arrive with the same answer. And so we can say that either of the two formulas, you may use that one to solve for the arithmetic series, but you need to be particular with the prior steps you need to perform, and so you will be able to use effectively the formula for the arithmetic series. Okay, so let us have our second problem. Find the sum of the first 50 terms of the arithmetic sequence if the first term is 15 and the 15th term is 113. So of course, before we start with our solution here in the second problem, you need to think as well of what formula are you supposed to use or which one is more advisable. But of course, I'm gonna share to you the process in dealing with the shorter formula for arithmetic series. But if you are going to think, if you are going to use for the shorter formula, so we don't have the value again for the 50th term. At the same time, if you are going to use the longer formula, I think we are lacking of one important detail, and that is common difference. So that means we need to look first for the value of the common difference. And so how? So let's sort the data given here that would guide us to find the common difference. So as of now, let us consider that we do have the sequence from the first term up to the 15th term for the meantime. And so we can say that our a sub 1 is 15, our n is 15, and our a sub 15 is 113. And so substituting this in our formula for arithmetic sequence, guys, and of course, we have our a sub n because we assume that as of now, we do have 15 terms, and the 15th term is 113, and so our a sub n is 113. A sub 1 is 15, n is 15, and d is missing yet. And so performing the indicated operation, 15 minus 1, 14, multiplying it with d, so 14d. And so, of course, let's combine the constants. So we do have here the shortcut. I just transposed 15 to together with the 113. So we will have 113 minus 15. So we will have 98, but it is not yet done because we are supposed to divide both sides by 14 to isolate the d. And so we got d equals 7. Okay, so since we do have our value for the common difference already, we can now sort the necessary data and proceed with finding the value of the 50th term. So that's your next agenda. You need to find the value of your 50th term if you wanted to use the shorter formula for arithmetic series. And as I said a while ago, I'm gonna focus with the shorter formula. And so, my second task is to find the value of my last term, which is a sub 50 or the 50th term. So, substituting all the formula here, I mean the given data, so we can have a sub 50 is equal to 358. And of course, after this, since we do have the value for the 50th term already, we can now proceed with the formula of arithmetic series. So here, I will just list down all the data so that I will not be able to mislook the data to be substituted in the formula. So here, n is 50 because we are tasked to find out the sum of the first 50 terms. And we have here in the given data, our first term is 15. And our a sub n, the value that we've got a while ago is 358. This one. And so we can now use that. And we can substitute in the formula. So we have 15 plus 358. We have 373. Multiplied with 50 and then divide by 2, or let's simplify first the 50 divided by 2, which is 25, and next to that we can multiply directly to 373, and so we got an answer which is 9,325. So here I'm gonna show you the other solution using the other formula, the longer ones. So first, I'm gonna list here all the necessary data for the formula which are already given in the problem, or the data that we got a while ago. So of course here in this problem we are missing with the common difference, which is 7, that we already got there in our previous solution. So our d is equal to 7, and so we can substitute with the longer formula. So we have here n is 50, our a sub 1 is 15, n is 50 again, and d is 7. And of course, performing the indicated operations, applying the PEMDAS rule, we would have 25 times 373, and you can see here that we got the same answer again, which is 9,325. So I provided you already two problems where in either of the two formulas we can arrive with the same answer as long as we know the prior steps or the prior details that we need to look for before pursuing the arithmetic series formula. Okay, so let's have our practice number 3. Find the sum of the first 18 terms of the arithmetic sequence whose general term is a sub n equals 15 plus 8n. So in this scenario, this is quite different from the two problems that I presented to you, but this is way better or way easier than the first two problems. So here, to solve this problem, so again, I'm emphasizing the use of the shorter formula for arithmetic series, and so my first target here is only finding the values of both first term and last term of the given sequence. So how? By evaluating only the algebraic expression, or let's say the equation given here, okay, or the general term given here. So we have 15 plus 8n. Since I'm looking for the first term, so I'm gonna substitute n equals 1. So here, performing the indicated operation, I would have first term, which is 23. And also, I would like to find out the value of the 18th term, which will be needed in my formula later on for arithmetic series. And so I would have 144 plus 15. The 18th term is equal to 159. And so I can now proceed with the formula of arithmetic series, which is the shorter ones. Okay, so here are the data given, or here are the data we gathered already, and now we can substitute in our formula. So we have 18 for our n because we are tasked to find out the sum of the 18 terms. And for our first term, stated here, we have 23, and our 18th term we got a while ago, which is 159. And so perform the indicated operation, 23 plus 159, 182. And simplify 18 divided by 2, which is 9, and then multiply with 182, you would have 1,638. And you're done. Okay, so let us have another problem for this topic. So find the sum of the first 24 terms of the arithmetic sequence: 5, 16, 27, 38, and 49. So here again, I'm gonna use the shorter formula for the arithmetic series. And so I'd like to find out first the value of the 24th term of the sequence. Okay, so I know you are particular already with finding the common difference, and so these are the necessary data for the formula for us to be used to find out the value of the 24th term. So going back with the arithmetic sequence formula and substituting the data here, we have a sub 24 equals 5 for the first term, plus quantity n is equal to 24 because we are looking for the sum of the 24 terms, and of course our d, which is 11. Okay, so perform the indicated operation. 24 minus 1, it's 23, multiplied with 11, ayan, following the PEMDAS rule, 253, and then added by 5, and you would get 258. And so, since my data is complete already, I can now use the formula for arithmetic series, which is the shorter ones. Okay, so listing the data necessary for my arithmetic series formula. So here, I'm gonna substitute already. So I would have 5 plus 258 is 263, multiplied with 24 over 2, which is equivalent to 12. And so 12 times 263, we would have 3,156. So the sum of the first 24 terms of the arithmetic sequence 5, 16, 27, 38, and so on is equal to 3,156. And we're done. As easy as that. Okay, so let us have a short activity. You may pause the video for a while, and if you are done answering the given problem, you may now resume watching the video. So these are the two problems you are supposed to answer for the meantime. And again, if you're ready to check your answer, you can now proceed or resume watching the video. So these are the answers for the two problems I presented. So we're done. So thank you so much for watching this video, and hopefully you learn about finding the sum of an arithmetic sequence. So see you in our next video lesson. Thank you so much for watching.